Hello and welcome back to SQA Higher Maths applying differential calculus. We're going to be looking at the area between two curves in this section. So let's go straight into it. The area between two curves between x equals a and b, so here's a diagram below, so between these two limits, is calculated as the integral from a to b of the upper curve minus the lower curve dx. Okay, so if we know f of x and we know g of x, we'd subtract them first because that reduces the amount of work we have to do. And that'll give a third function of x. And then we just integrate that and evaluate the limits like we have been doing. So again, there isn't really too much new to do here, guys. It's just an idea that's using stuff that we already know. So if we have, just like in the previous lesson in lesson 4 there, if we're looking at areas above and below the x-axis, we needed to split it into two separate areas. That's also the case if we have an area above one curve, or in this case above the line, and an area below the line. We need to do the two integrals separately. Otherwise, what happens is, just like in the previous video there, this area would cancel out with this area. Okay, so must do them both separately if that is the case. Okay, so as it's saying here, go from A to B, then from B to C. Right, let's go into an example. Calculate the shaded area enclosed by the curves with the equations y equals 6 minus 3x squared and y equals negative 3 minus 2x squared. Okay, so we want to integrate from here to here, and we want to do the upper curve or the top curve minus the lower curve or the bottom curve. Okay, right. We don't actually know what the limits are here, but to find the points of intersection, we just equate these two terms. So we're finding out when 6 minus 3x squared is equal to negative 3 minus 2x squared. So equate them, bring everything onto one side. So 9 minus x squared equals 0. Use the difference of two squares, and we get the x coordinates of negative 3 and 3. So there isn't any special case here like there was in the questions here. Okay, we're just looking at one area. So we're going to integrate the upper curve or the top curve, subtract the lower curve or the bottom curve. So I've just written the integral from negative 3 to 3 of the top curve minus the bottom curve. So it's the one on top minus the one on the bottom. Be very, very careful here, guys. You're doing minus 3x squared minus 2x squared. So basically minus 3 plus 2, which will be minus 1x squared. And again, here 6 minus minus 3 is 6 plus 3. Okay, so we just need to integrate 9 minus x squared and evaluate that between negative 3 and 3. So again, hopefully the integration of this is reasonably straightforward for you guys now. Substitute in 3 and negative 3. Obviously be very, very careful with your negative signs. So 27 minus 27 thirds, so it's basically 27 minus 9, which is 18. Negative 27 minus negative 27 over 3 is basically negative 27 plus 27 thirds. So we essentially got 18 minus negative 18, which is 18 plus 18, which is 36 square units. Okay. Right, there's a couple more examples. I will do those in separate videos, but the method will remain the same. Find the points of intersection if necessary. Sometimes they're given, sometimes they're not. And then just the integral of the top curve minus the bottom curve, or the upper curve minus the lower curve, between those 2 points of intersection.